Today we discuss about angle of contact and meniscus formation, investigating the mechanical properties of fluids. Here you see this is a capillary rise. Water wets the surface, resulting in a concave meniscus in a capillary tube due to adhesive forces exceeding cohesive forces. In this case, adhesive force is always greater than cohesive force. First, have to know what is the meaning of adhesive and cohesive forces. Actually, adhesive, adhesive forces are the forces between dissimilar molecules, dissimilar similar molecules. For example, here in the case of the attraction between molecules of water and glass. So this is adhesive force. And there is another word, cohesive force. What is that? Cohesive. Cohesive force. Cohesive means similar molecules. Similar molecules. Similar molecules mean the attraction between the same molecules, the attraction between the water molecules itself, that is cohesive force. But in this case, what we get that the adhesive force is greater than cohesive forces. So there is a capillary rise in the case of capillary in water, right? So water wets the surface, resulting in a concave meniscus, and the meniscus is also concave. So this is concave meniscus in capillary tube due to adhesive forces exceeding cohesive forces. And also, if we find the angle of contact, here you find the angle of contact is less than 90 degree. That is acute angle. So the meniscus will be like this. But here you see mercury does not wet the surface, resulting in a convex meniscus. The meniscus is convex. You see, this is convex meniscus due to cohesive forces exceeding adhesive forces. Here cohesive force is greater than that of adhesive forces, and the angle of contact is greater than 90 degrees. See here, this angle of contact, this theta is always greater than 90 degrees. This is theta, and this theta is greater than 90 degrees. So this is the case of mercury in glass tube or capillary. So this is the case of water. Angle of contact is less than 90 degree, though it is impure water. Remember that it should be impure water. But in case of pure water, the angle of contact is 90 degree. And in case of mercury, it is more than 90 degree, that is an obtuse angle. It is the angle of contact is theta is equal to obtuse angle. Obtuse means greater than 90 degree. Obtuse angle. So this is the reference to that angle of contact and meniscus formation. Next one important thing is this one, the observation, the two liquids, two different shapes. Here you see what case on water. In case of it is concave meniscus, because the adhesive force adhesion force of adhesion is greater than force of cohesion, and there is a capillary rise. This is a convex meniscus. Here we get cohesion forces greater than adhesion. Cohesion forces is greater than adhesion. Okay, and here you see the scenario. When a glass capillary tube is dipped into a liquid, the surface does not remain flat. Case of water, but this is you have to case of impure water. Remember that is impure water. In impure water, the liquid climbs the wall, the surface curves upward. This is concave meniscus. In this case, it is concave meniscus for water. Case B for mercury, the liquid dips at the walls. The surface curves downward. That is convex. We say it as convex meniscus. Convex meniscus. So the two liquids, two different shapes. And third one is quantifying interaction. We have to know the interaction, different interaction. There is angle of contact. How to find the angle of contact? Definition: angle between the tangent to the liquid surface. The angle between the tangent to the liquid surface at the point of contact and the solid surface measured inside the liquid. This is angle of contact. Suppose it is for mercury. Mercury is like convex shape. So there is a tangent here, red line. This is a tangent here, right? And this is the point of contact. And the tangent to the solid surface is this one, to the solid surface. So there is an angle between these. Here the contact angle inside the liquid always. Identify the point of contact first. This is the point of contact. Draw a tangent to the liquid surface. Draw a tangent to the liquid surface. Measure the angle to the liquid phase, or else the point of contact will be in the liquid phase. This is the angle of contact. But here you see angle of contact is greater than 90 degree. This is the case of mercury, case B. So in this way you have to find the angle of contact. Quantifying the interaction, the angle of contact. Here you see in mercury the angle of contact is always greater than 90 degree. Case study: water and glass. Primary statistics. Acute angle, the theta is less than 90 degree. Here you find that theta is always less than 90 degree. That a pure water and glass, theta is equal to 0 degree. The liquid runs parallel to wall. If it is pure water, then the surface of the liquid will be like this. If it is pure water, the surface of water will be straight line. The angle theta equal to 90 degree. Theta is equal to 0 degree, that is, it is parallel to the surface. Top water and glass, theta is nearly 8 degree and it will be concave. This is for theta equal to theta is less than 90. For pure water, the theta equal to 0, that is, liquid runs parallel to wall. Parallel to this wall, right? And tap water, glass is 80 degree, resulting wetting because the angle is acute. The liquid spreads out and adheres to the surface. So here you can find the angle is acute angle. You see, this is the surface. The angle will be always, and this is the point of contact, right? This is the point of contact. So there is a tangent in this direction. So this point of contact, is angle is theta, and this theta is nearly 80 degree in case of impure water, nearly 80 degree, and it forms a meniscus in this way. Meniscus in this way. Concave meniscus. It forms a concave meniscus. The result, wetting because the angle is acute, the liquid spreads out and adheres to the surface. Mercury and glass, non-wetting liquids. Primary statistics. Of this angle, theta is greater than 90 degree. You see, this is the point of contact, and this is the tangent, and this is another tangent to the solid. So the point of contact is greater than 90 degree. Not this angle, but this angle. Theta is greater than 90 degree. The angle of theta will be always inside the liquid, not outside. This is not right. This is the angle theta, and this is greater than 90 degree. Data points: mercury and glass, theta is equal to 135 to 145 degree. The result, non-wetting. The liquid refuses to spread, beading up to minimize contact with the surface. This is the result for mercury, non-wetting liquids. Next point is this one, that is molecular metal cohesion versus adhesion. The shape of the meniscus determines the competition between two molecular forces, adhesive force and cohesive forces. You see, attraction between different molecules is adhesive. That is, attraction between glass molecules and water molecules is known as adhesive forces. Cohesive forces, attraction between same molecules. It is water or mercury molecule, this is known as cohesive forces. So surface tension is a different manifestation of strong cohesive forces. Surface tension is a direct manifestation of the strong cohesive forces. Reactor analysis, why water curves up? Why water curves make curves in the battle? Adhesion wins if force of adhesion is greater than force of cohesion. Force of adhesion is greater than force of cohesion, then the result that the water will form is concave meniscus. Concave meniscus in this way. Adhesive force is stronger than cohesive force. The net resultant force vector points outward with the solid. Physics rule: a liquid surface at rest must be always perpendicular to the net force. Perpendicular to the net force. Result is to stay perpendicular to the outward force, the surface curves upward concave. Surface force upward concave. This is the resultant force. This is the force of adhesion. This is the force of cohesion. So to stay perpendicular to the outward force, the surface curves upward or concave. So in this case, if the force of adhesion is greater than the force of cohesion, it will be concave. Vector analysis, mercury curves down. Mercury curves down. Battle, cohesion wins. That is, force of cohesion is greater than the force of adhesion. In this case, where the surface tension, mercury has 0.465 Newton per meter, much stronger than that. Water is 0.075 Newton per meter. Cohesive force is massive compared to weak adhesion. The net resultant force vector points inward. The net resultant force points inward. Higgs rule: to remain perpendicular to the inward force, the surface bulges downward, and so the result is convex meniscus. So the result is convex meniscus in case of mercury. Practical implications: to wait or not to wait. When force of adhesion is greater than force of cohesion, it is form of waiting. Water spreads and clings to lab equipment. This creates to concave meniscus, requiring careful volume reading at the bottom of the car. Mercury forms spherical droplets and does not stick to glass. It is spilled. If it is spilled, it breaks into beads rather than soaking the surface. Why? Because here the force of cohesion is greater than the force of adhesion. That is the reason that it forms beads. Now the table of two liquids. It is a property angle of contact. For water, it is theta should be less than 90 degree. For mercury, theta should be greater than 90 degree obtuse angle. Meniscus should be concave for rising and convex for depressed. Weighting nature weights surface. Mercury does not weight. And dominant is adhesion force is greater than cohesion force. Here cohesion force is greater than adhesion force. Force of adhesion. The physics of interaction: adhesion container, liquid surface, cohesion self, liquid surface. Key takeaway: the angle of contact is not random, it is the geometric result of a molecular tug of war. Whether a fluid climbs a wall or retreats into a sphere depends entirely on whether it prefers the company of the container or the company of its own kind. Thank you everybody for watching this video. Thank you.